In this video, I'm going to work an example for you from Anton page 168. This is number 40. The original problem starts with 3x squared minus 4y squared equals 7. Your instructions are to use implicit differentiation to find the second derivative. Your first step is to find the first derivative. Using implicit differentiation, the derivative of 3x squared is 6x. And the derivative of negative 4y squared is negative 8y dy dx. And the derivative of 7 is 0. I'm going to solve for dy dx. Move the 6x over. Divide both sides by negative 8y. For our final result, dy dx, the first derivative, equals positive 3x over 4y. I'm going to box it. We're going to need this again. We're going to need the original function again too. Now I'm going to take the second derivative. So I'm going to get d squared y dx squared. I need to use the quotient rule. Low d high is low d high minus high d low is high d low is 4 times the derivative of y all over low squared 4y squared is 16y squared. What you have to do now is replace dy dx with what dy dx equals. Minus 12x times what dy dx equals 3x over 4y. All over low squared. I'm going to remove the 4 from top and bottom. By dividing top and bottom by 4. I'm going to distribute the top here. And I'm going to multiply top and bottom by 4y to clear the denominator here. Let's see if I'm able to change the color of my pen for a moment. Hold on. That changed the color of everything. It's okay. I'm going to multiply top and bottom by 4y to clear the denominator. And what I have now is 12y squared, because you have to distribute that 4y on top, minus 9x squared all over 16y cubed. At this point, I'm going to look back to my original problem, which is sitting right here. 3x squared minus 4y squared equals 7. This has a relationship to 3x squared minus 4y squared. If you factor out a 3, get 4y squared minus 3x squared all over 16y cubed. 4y squared minus 3x squared is equal to negative 7. That's the final answer for the second derivative. And the question you're probably asking yourself, let me see if I can switch colors again. The question you're probably asking yourself is, how do I know to look for this in the end? How did I know that this would contain that? And the reason is, these problems where you find the second derivative, that always happens. The original problem shows up as you're doing your work, and you can substitute in this case 3x squared minus 4y squared equals 7. You can get rid of the 3x squared minus 4y squared and find an answer that does not include it. So the key steps to this are: 1. Find the first derivative, box it. 2nd, use the first derivative to get the second derivative, but when it has dy dx in it, go back here and substitute that in. Next, multiply it out. You have a fraction inside of a fraction here in the numerator. You have a fraction in the numerator, so you multiply that out, top and bottom, by 4y to clear that denominator. Then you look at this and see if you can find the original problem lurking inside. That's how you find the second derivative using implicit differentiation. This is not my normal technology for doing the video. I hope it is still useful to you.